Hi, I'm Andrea and welcome to Productive C#. In this video, I'm going to explain the difference between value types and reference types in C#. This is a very important thing to understand when you are new to the C# language. So the best way for learning this is by example. Let's start with this console application, and I have defined a value type called point. In order to define a value types, I'm using the struct keyword in C#. This type contains an X and a Y that basically represents a point in space. There's a constructor that takes an X and the Y, and there is a toString methods that basically returns a string representation of point. The main program instantiates point 1, 1, then assign the point to point 2 and attempts to change X and Y of point 2, and then is printing point 1 and point 2 to the screen. So let's have a look at what actually happens in memory when you execute this code. As you can see, we are printing 1, 1 and 2, 2. So this means that point 1 and point 2 are actually holding different location of the data. Why I'm saying that? The reason is that when I do an assignment, point 2 equals point 1, what really happens is that a copy of the memory location, the memory where the point 2 represents, is copied into another location where the point 2 represents. So this means that point 1 and point 2 are actually two locations in memory that are completely independent from each other. If you attempt to change any information inside a memory location of point 2, nothing happens on point 1. They are two completely isolated locations. So a value type holds the data within its own memory allocation. And the semantics is fairly clear. When you do an assignment to another variable, a copy by value occurs. And if you change those values, nothing happened to the original value because they are completely independent from each other. Let's now see what happened when I change this struct to be a class. And class is the way you define reference types in C#. Now, the same program code still compiles, but the semantics now is completely different. What happens at runtimes is different. Let's run this program and see what happened. Now, I'm printing 2, 2 and 2, 2. That's fairly interesting. What happened to 1, 1? The reason is that reference types contains the memory address to another memory location that holds the data. So actually point 1 and point 2 are just pointers to another memory location. When you do point 2 equals point 1, and those types are reference types, you're actually copying a pointer to another. And then later on, when you actually change X and Y with the point 2 reference type, you are also changing indirectly where point 1 points to. Because at the end of the day, point 1 and point 2 are pointing to the same exact location in memory. So when you do an assignment to another variable using reference types, you're only assigning a reference to the location of where the data is stored. So the two variables are still kind of dependent from each other. And you need to keep this in mind when you work with C#. So if I change point 2x and point 2y, I'm also changing point 1x and point 1y. So that's extremely important. This is actually the main difference between value types and reference types. The semantic of the behavior when you use value types and reference types is very different. Value types in C#, like all the numeric data types, like int, float, double, are actually value types. Boolean, characters, datetimes are also value types. So anything that is defined as a struct is a value type in C#. All value types implicitly inherit from system.valueType, and if the most important things about value types is actually the semantic. Um, Pay attention that some articles online say that value types are usually allocated on the stack, and the usually part is very important. They're not always allocated on the stack. So value types are allocated on the stack only when used directly inside methods. And this is actually very efficient because garbage collection doesn't take place. So the performance is quite good when memory is allocated on the stack. However, if you use a value type inside a class or another reference types, they will be allocating on the heap. So, and there will be the memory they are using will be garbage collected when the actual reference type will be collected. So that's something to keep in mind. So the location where the data is stored in memory, either the stack or the heap, doesn't really matter in terms of what a value type is. So what really matters is the semantic, or the fact that a value type holds the data within its own memory allocation. What are the reference types? So like strings, arrays, objects, and delegates, and anything that is a class in C# is a reference type and behaves with these semantics in mind. So the semantics, the reference types contains a pointer to another memory location that holds the data. And when you assign reference types, you're only assigning this pointer to another. You're not doing any copy by value. The good things about this is that it's extremely efficient to do an assignment of a reference type. While if you do an assignment between value types, this could be expensive, especially if the value type requires a lot of bytes in order to be allocated. So it's always a good practice to keep your structs, your value types, basically less than 16 bytes. That's kind of a general guideline. It's also quite a good practice to make sure that the value types are immutable. So that it's not possible to change the memory that a value type holds after it's been created. Like for example, this point here, when it's been defined as a struct, is actually a mutable struct, and it's usually not a good practice to have these sort of things. And if you actually look closely at the .NET framework, all the value types defined by the framework, like date time or time span, are actually immutable. If you call methods on those types, they will return new copies of value types. And I think I've covered the main difference between the two value types and reference types. They are very important to understand. If you are confused about this, I recommend you to actually play a bit with struct and classes, or specifically primitive types or enums and strings, and try to see if you can understand the behavior. Another interesting thing you could do is to actually test if a particular type is implementing value type. And this is a way to actually check that point 1 is a value type or not. If I run this, you will probably see that it's false, because now point is defined as a class. So it's actually not implemented value type. So it's false. All reference types implement system.object. So they inherit from system.object. If I change this to struct and I run this code again, you will see that all point 1 is actually a value type, is inheriting implicitly value type. And so the answer is true. This is a very quick way to check if a type is actually a value type. It's not really commonly used in practice. It just can be used by you to understand better the difference between value types and reference types. Also, if you are considering doing the C# specialist certification, this is very important to understand, because there will be questions on this topic. And that's it. Thank you very much for watching.